AP and Honors Chemistry, this is the answers video for the Day 16 assignment. I will just present a limited number of answers, enough that you can kind of get an idea of how to do the problems, and then you go from there and ask questions when you need to. Okay, so the first page is the usual, it's a pre-assignment, and you watch the video to get those answers. They're basically definitions. Alright, so on page 2, what I'm asking you to do here is compute the atomic mass and the molar mass for each of these compounds. So they're things you've heard of: carbon dioxide, this is vinegar, vanilla, and peppermint. So why don't we do peppermint here? So you start off with the element is C, and you have 10 of them. And the atomic mass is, for carbon, is 12.01. So you're going to put that here. And you multiply those and you get 120.1. Okay. All right. Next is hydrogen. 20 of those. And off the periodic table, you get the atomic mass of 1.01. And that gives you 20.2. Okay, and finally oxygen, there's one of those. And periodic table says that the atomic mass for oxygen is 16. Alright, so we just add these up and we get 120, 140.3, 150.3, 156.3. That's atomic mass units. I'm not going to worry too much about significant figures here, but if you do them, you do them. But we're not limited by these numbers because these are exact integer values, so they really have an infinite number of significant figures. Probably the limiting one would be the 1.01, but I'm going to go ahead and use 4 here. Okay, now, so that's the atomic mass. It's the mass of one molecule. The molar mass and that's going to be 156.3 grams. The only thing that changes is the unit of measure becomes grams. Okay? All right. You can do the rest. Ask for help if you need it. Okay, next what we're going to do is, here's a table that's filled out for you. You're going to fill out tables for 3 more of these. So it's carbon dioxide. So there's carbon, there's oxygen. So you need 1 carbon and 2 oxygens to produce 1 CO2 molecule. Just like you need 2 wheels and 1 seat to make 1 bicycle. All right, now the atomic mass is 1 times 12.01 for carbon. We just got that off the periodic table. For oxygen, it's 2 times 16, so that's 32. And when you add those two, you get 44.01 atomic mass units. But again, our thinking is to get away from dealing with atoms and molecules and atomic mass units and deal with these big baskets called moles. So a big basket of 6.022 times 10 to the 23rd. So if you multiply an atom of carbon dioxide times a mole, you get 1 mole of carbon atoms. If you multiply 2 atoms of oxygen times a mole, you get 2 moles of oxygen atoms. And of course, 1 mole of CO2 times a mole gives you 1 molecule of CO2 plus times a mole gives you 1 mole of CO2. Okay. So now what that means though is, because we use this magic number, this 12.01 AMU converts exactly to the same number of grams, 12.01 grams. The 32 AMU converts to 32 grams. 44.01 AMU converts to 44.01 grams. This is the only number that will make these numbers convert directly to the same number but in grams. Okay? Now over here is something that I didn't show you on the video. It's how many atoms or molecules is that. So if you have 1 mole of carbon, you have 6.022 times 10 to the 23rd carbon atoms. If you have 2 moles of oxygen atoms, you have 2 times 6.022, or this number right here, of oxygen atoms. And if you have 1 mole of CO2, then of course you have a mole, 6.022 times 10 to the 23rd molecules of CO2. All right? So now we're going to go ahead and answer a couple questions. I want to show you how I'd like you to write these out. So how many CO2 molecules in 2 moles of CO2? So here's the way you interpret this, and the reason this has this border around it, this dashed line, is it's saying that if you want to make 1 mole of CO2, you need 2 moles of oxygen and 1 mole of carbon. If you want to make 1 mole of CO2, you need 12.01 grams of carbon and 32 grams of oxygen. And that 1 mole will produce 44.01 grams of CO2. And then if you want to know how many actual atoms you have, there they are. So 1 mole of CO2 will have 6.022 times 10 to the 23rd carbon atoms. 1 mole of CO2 will have 2 times 6.022 times 10 to the 23rd oxygen atoms, and 1 mole of CO2 will have 1 mole of carbon dioxide atoms right there. Okay, so all you're doing is scaling it. It's like if you need certain ingredients to bake a cake, and you want to bake 3 cakes, then you need 3 times as many of the ingredients. Okay, so how many CO2 molecules in 2 moles of CO2? So in 1 mole of CO2, there's that many molecules. So in 2 moles of CO2, if we wanted that to be 2 moles, we'd need 2 times that many molecules. So here's how I'd like you to write out the answer as a complete sentence. Okay, a couple things I want you to notice about how I wrote this out. I say there are, in 2 moles of CO2, there are 2 times a mole number, that mole number. Now, I'm not going to ask you, only when you're dealing with atoms and molecules over here in this column, to actually multiply it out. If you did, you would get 1.204. We don't care about that. Okay, now the others I do want you to multiply out and get an answer. Now, notice how I write molecules CO2. So you write the unit of measure, molecules, and then in parentheses you put the substance, because we're dealing with different substances here: CO2, oxygen, and carbon. Okay, so there are 2 times this number, molecules CO2 in 2, and notice how I write mole CO2. Mole is abbreviated MOL. Even though the word is only MOLE, they still decided to chop the E off the end. So it's MOL, meaning the unit of measure, moles, CO2. So that's how you would write that answer. Okay, let's go on to number 2. How many grams is 2.5 moles of CO2? Well, 1 mole of CO2 is 44.01 grams. So 2.5 moles of CO2 is going to be 2.5 times 44.01. So let's go ahead and write that out. And in this case, I do want you to multiply it out, the number. And that's going to give us 110.03. And watch how I write it: units of measure, and then in parentheses the substance, CO2. Grams of CO2. That's the way you would read that. And finish the thought in, again, unit of measure, and mole, when you put it in an equation like this, is just MOL, not MOLE. Okay, there are 2.5 times 44.01, so show the calculation, equals 110.03 grams CO2 in 2.5 moles of CO2. Okay, I'm going to help you fill out this table here, show you how to do that. So this is glucose. It's the kind of sugar that's in your blood. Anything you eat that's a carbohydrate, whether it's a chocolate chip cookie or a potato or rice or bread or ice cream, turns into this kind of sugar in your blood. Okay. All right. So the way we're going to do this, you notice I gave you an extra line here because you've got 3 elements involved. So we're going to write C, H, and O, and together they're going to be put together into glucose. Okay, so how many atoms? Well, we have 6 carbon atoms, 12 hydrogen, and 6 oxygen. Now be careful. What do they add up to? All of those go together to make one glucose molecule, okay? Not 24, okay? So be careful on that one. Now with the masses, you do add them, okay? So what's this going to be? It's going to be 6 times, of course, periodic table. I'll still show it to you a few times. You know where to find it. 12.01. And that's going to equal 72.06. And that's AMU. We're dealing at the molecular atomic level. Atoms and molecules here. Okay. Hydrogen, you got 12 times 1.01. And that's going to give you 12 point, just check something, 12.12. And again, it's AMU. Okay, and finally 6 oxygen. So you have 6 times, again, you go to the periodic table, it's right there, 16. And that's going to be 96 AMU. Now you add those together, it gives you 180.18. So 180.18 atomic mass units. That's the mass of a glucose molecule. Okay, so now number of moles, you're simply multiplying this by 6.022 to get the number of moles. It's just going to be 6 moles. 6 atoms turns into 6 moles. 12 atoms turns into 12 moles. 6 atoms turns into 6 moles. And 1 molecule turns into 1 mole of glucose. Okay, so again, the significance of this magic number is not that. You could have picked any big number and just said, okay, 6 is 6 moles, it's 12 moles, whatever. This is where the magic comes in, and that is the number here is the same. 72.06 grams, something we can measure in a laboratory. 12.12 grams. 96.00 grams. And when you add that up, you get 180.18 grams of glucose. Okay, so how many atoms or molecules is that? Well, you have 6 moles, so it's going to be 6 times this many atoms or molecules. 6.022 times 10 to the 23rd. And in this case, it's atoms. I'll write that out here. Okay, so you do not have to do this calculation, multiply 6 by 6.022. That's what I said before. Here, it's 12 times 6.022. And that's atoms. And here it's 6 times 6.022 again for oxygen. Okay, and then for the entire glucose molecule, you have 1 times 6.022. And again, you don't have to actually do these. Just for this column, you don't have to do. I want you to do it for everything else. And that's molecules. That's how many molecules of glucose you would end up with. Okay, so that's how you fill out these tables. If you have questions, ask me. Okay, so I said it's fructose. It could be. Actually, they have the same formula. We'll talk about that at a later time. Okay, so how many fructose molecules is 3.1 moles of this molecule of fructose, okay? Fructose, glucose, we'll call it either one here. Okay, so if in 1 mole of fructose there is this many molecules, then in 3.1 there's 3.1 times this many molecules, okay? So write it as a complete sentence. What's the actual number of molecules you have here? It's a big old number. Okay, and I said you don't have to multiply this out in this column. So we're going to say molecules, unit, that's the unit of measure, it's what we're talking about. And what's the substance? C6H12O6. Now I don't mind if you call it FRUC, F-R-U, or something like that to abbreviate it. That's okay, rather than writing that every time. In 3.1. Again, watch how I write the units. For moles, it's mole, M-O-L, of, and I'll do it this time, I'll write FRU. Okay? I was calling it glucose, it's fructose. They got the same formula, okay? Okay, so you could either write fructose like that or like that. Okay, let's go down. Let's do another one. How many grams of oxygen in 1.6 moles of this? So in 1 mole, you come up to the oxygen row, and there's grams. So in 1 mole, there's 96 grams of oxygen. So how much is there in 1.6 moles? So there are 1.6 times as much. And I want you to multiply this out. 1.6 times 96. 153.6. And we're talking about oxygen, grams of oxygen. And again, I'll abbreviate it, I'll call it fructose. Okay? So there are 1.6 times 96, which equals 153.6 grams of oxygen in 1.6 moles of fructose. So again, let's be sure we understand this process. In 1 mole of fructose, there's 96 grams. So if I want to make 1.6 moles of fructose, I need 1.6 times 96 grams. Again, just like baking more cakes than the recipe. This is a recipe for 1 cake, all of this. What if you want to make 2 cakes? Then you'd have to double all of this, all right? Be sure you see what's going on there. All right. I'm going to do one more with you. All right. How many... see if I can get all this on the screen. How many oxygen atoms, I'm doing number 15. How many oxygen atoms in 2.5 moles of fructose? Okay, so let's see. In 1 mole of fructose, there are, here's the oxygen atoms, 6 times 6.022 times 10 to the 23rd atoms. So in 2.5 moles of fructose, there's going to be 2.5 times this number of atoms. So again, you don't have to actually calculate out the final answer. Watch how I do it, okay? So there. Okay, now I'm going to put the units of measure on. Molecules. There's no abbreviation for molecules. You just have to write the word out. Of oxygen. Again, watch how I write moles, because this is the one you're going to do a lot in this class. Moles of, and I'll write out the formula this time. Again, you have the option to do that or abbreviate it. Okay, so there are 2.5 times this number right here. Okay, 1 mole is this many. 2.5 moles is 2.5 times this many, so that's what I wrote here. Molecules of oxygen in 2.5 moles of C6H12O6. So I think that's enough examples to get you started, but if you have questions, ask me. Now I want to go to the last page. So you're going to be asked to do CH4 on your own. All right, now this has to do with molar masses and the way to express them, okay? So HBr, so do the calculations down here. So HBr, if you look at the subscripts, there's 1 hydrogen and 1 bromine. Okay, so write the number of atoms and then the atomic mass right there, or molar mass. We're talking about moles now. All right, and for bromine, come over here. Check it out, 79.90. And there's 1 of those. Okay, when you add those two together, you get 80.91, and it's grams per mole. In other words, in 1 mole of hydrobromic acid is what that's called. In 1 mole, you have 80.91 grams. Okay, it's going to weigh 80.91. So if you have 6.022 times 10 to the 23rd of these molecules, it's going to weigh 80.91 grams. So the molar mass is 80.91. Now the equivalency is this. 1 mole, equivalencies are always 1 mole when you're doing molar masses there. HBr equals and you also write HBr after both sides, okay? So 1 mole HBr, 80.91 grams of HBr. The shorthand is just molar mass, MM, equals kind of what I wrote down there. Grams per mole. That's the way it'll appear in a problem. They'll say the molar mass of hydrobromic acid is 80.91 grams per mole, and then they'll go on and you'll use that later on. Now, conversion factors, you take the equivalency, you put one over the other, and then you flip it. And why do you do that? We'll talk about, you're going to find out very soon when we get into stoichiometry. You can put an equal sign between these. I like to put an or, because as you see, when we get into stoichiometry, you're going to use one of these two. So I'm now going to put the 80.91 on the top. Okay, so these are both true statements. It's like saying there's 12 inches for every 1 foot, which is a true statement, or there's 1 foot for every 12 inches. That's also a true statement. These are just two different ways of saying the same thing. Okay, so go ahead and do your calculations for these down here, and then you can go ahead and fill this table out the way I showed you. Again, if you have questions, ask me in class. Okay, I want to see you getting correct answers for everything going forward. No more wrong answers. Okay, all right, so I'll see you in class.